Chapter 6, Simple Problem Number 1. Shown below are boxes that are being pulled by a force F along frictionless surfaces, accelerating towards the left. The masses of the boxes are indicated in each figure. Will the magnitude of the tension in rope A on the left be greater than, less than, or equal to the magnitude of the tension in rope B on the right? So, instinctively, if you want to look at it that way, they'll have the same acceleration. All the boxes will have the same acceleration. Why? Because the total force is F, and acting on a box of sort of mass 3m. Imagine we replace these with a box of mass 3m. And we replace these, and they'd also be replaced with a box of mass 3m. Now, if we look at the acceleration on the left, we have a total force of F equals a total mass of 3m times A, which implies that the acceleration of that box, that red box, as you would be F over 3m, probably more likely written as 1/3 F over m. And if we're looking over here, we again have a total force, a net force of F on the blue box with a total mass of 3m times its acceleration. And so its acceleration turns out to also be 1/3 F over m. And I'm going to call this acceleration on the right and acceleration on the left. And so we see that the acceleration on the left and the acceleration on the right are the same. And therefore, all the boxes have the same acceleration of 1/3 F over m. Now, if we then what we're going to do is draw a free body diagram for just this guy. So I'm going to take this box, and I'm going to draw just the horizontal one, but I'm going to draw horizontally. There's a force, which is rope A, and there's an acceleration, which is A sub L. And analogously, I'm going to take this box, and I'm going to draw its free body diagram, and there'll be a force FB pulling over, and it has an acceleration AR. So now I can say, okay, well, FA will be the mass of the green box, which is m, times the acceleration, which is 1/3 F over m, or 1/3 the original force F. Whereas here we'll have FB equals, now this mass is 2m times the acceleration, which is 1/3 F over m. And we see that becomes 2/3 F. And so we can say that force B is definitely greater than force A. So magnitude of force A is less than the magnitude of force B. You could short-circuit some of the math by just realizing that the accelerations have to be the same, and therefore we have to pull harder on rope B just so as to produce the same acceleration.